What a day! What a day! Alright. Let's see, where are we at? We are at trying to understand what the heck we're trying to do. It's okay. Okay, I think there we go. Everything there is ready. And I guess I will do another typo. Okay. I need to start Steam as well. We can still start the server while we are waiting. Cannot object. Okay. That's fine. Like so, and close that. And what we're gonna continue to do is that we need a sampler. Right. I don't remember how to create a sampler, but we're gonna do that. Do I have any high-level abstraction? I don't think I do have any such things. C, BK, create sampler. This is all the information that we'll need: a device, a create sampler info, and then a place to store the sampler. This is again just for trying to remember how to actually create the texture and use it inside when rendering, because I don't remember how to do that. So we're gonna try to just try to figure this out. So sampler info, which will be of C, VK, sampler structure. What the fuck? What were they called? Create info. Yeah. And in here, let's see, what do I remember? Probably nothing. Yeah, I don't remember a single one of. Okay, at least I know the type. The type is easy. It's just a VK structure. Well, if I could spell structure, would be awesome. Structure type sampler create info. Pretty simple, right? Nailed that one at least. But let's see. What can we go? Vulkan sampler create. Let's see if I have creator. Okay, I just want to create. And let's see. I just want the. Well, there's okay, this is actually both of them quite what I need. But I was thinking of just reading the raw docs. But this one probably explains it a little bit better. Create image view. Sampler. Not saved. Sampler. Well, here we are. Sampler layout binding. Do I need to create that as well? Maybe I do. Let's see. Updating descriptors. But the thing is that I'm usually we'll look at descriptor at the first time in uniform buffer. Part of the tutorial in this chapter we'll look at the new type descriptor combine image sampler. This descriptor makes it possible. Combined image sampler. That's what I this thing. This descriptor makes it possible for shader to access an image resource through a sampler object like the one we created in the previous chapter. We'll start by modifying the descriptor set layout and descriptor pool, but we don't descriptor set layout. Okay, no. This is what we have been doing here. This is just okay. Now I'm back on it. And then descriptor set. Okay, no, so there's not. Okay, bro, I got so confused. Okay, good. We are chilling. We don't care about the pool sizes. We do care about the sampler create info wherever the hell that is happening. Great. Great info. But there's just descriptor layout, descriptor pool. I want to find create image view, create info, sampler create info here. Configure VK structure which specified all filters and transformation that this should apply. Create sampler min filter. The mag filter and min filter fields specify how to interpret texels that are magnified on a minimum. I have read this tutorial already once, but heck do I remember what I read when I first read it. I was like, well, I have no idea. Now at least some of these words make sense. How to interpolate texels that are magnified or minified. Magnification concerns the oversampling problem described above. And minification concerns undersampling. The choices are VK filter linear and VK filter corresponding to the modes demonstrated in image above. Okay, and then the addressing mode can be specified by axis using address mode fields. The available values are listed below. Most of these are demonstrated in the image above. The axes are called UV, and W instead of X, Y, Z. This is convention for texture space coordinates. Oh, so yeah, okay, sampler address mode. So that's just, now we're talking about, okay, now it's starting to make sense. Okay, I'll just repeat. Clamp border, I think I would prefer to do with my test. Okay, but we can do that at least to begin with. So we do this thing over here. C, VK. Is it just sampler address mode? Yeah. And then we can just do, what's it? Okay, repeat. Clamp to border edge. Clamp the border. Damn it, I was close. And then we will just do that. We'll yank that, paste it 3 times, and we'll change it to U, V, and W. If I could.
Hello!
Hello there!
Hi, Lucas. Enti.
Enti. Yeah, I see.
I like how you recognize almost no voice besides Harold. I love this.
Yeah, I don't even know who T-Chef is, to be honest. Like, T-Chef joins, I'm like, wait, I know this voice. Nah, I think if I actually just took a moment to recognize, but it's so much easier just to ask or then check. Yes. I don't have to use brain power. So how are you? Tell me how you are.
Oh, I'm doing fine, I guess. I'm up for like a couple hours, or like since in the morning, to be fair.
Okay.
So yeah, ate 2 like freezer pizzas today.
Freezer pizza?
So,
wait, what?
Yeah, like the pizzas you put in freezers.
Okay. Yeah.
Yeah, like the pure garbage. Yeah, exactly.
Yeah.
Then I saw the image of you T-posing.
Yeah.
Try to use AI websites to make it into a proper model.
Yeah.
All of them want to charge me.
Oh, yeah.
And yeah, I'm not really a good modeler myself, so
No,
I just wait for someone else in this Discord and making it.
Yeah, I was thinking maybe I should try to do just low poly, version of it, like.
Oh, that would be lovely. Or like a piece 2 style, or like piece X style, where the face is just stretched on the face.
Yeah, I mean, I think I'm still not really sure what's the actual. Like, I know kind of the art style, but I don't know yet who are the characters and what are their play style. Yet.
Harold needs to be in it.
Yeah, I'm thinking I would like to have Ben Bozo.
Alien.
Just for the and yeah, Harold, but also Ben Bozo for some reason, something either.
Yes.
And then
we need Harold to be a frog with glasses. Like invert emoji frog.
Yeah. But we need to kind of like think of like now for the first version, right? We need some at least 3 kinds of enemies. That's just an arbitrary number, but somewhere around this is the sweet spot, right? And that may include the boss. And then the main character, which will be some. I'm thinking just something simple as Commando from Risk of Rain. Very simple.
Oh.
Point and
Yeah.
click and shoot, like just that. But yeah, that's what I'm thinking right now. Then for items, we will just add basic like damage, attack speed, health. Like that's just stacks. Maybe we'll look into some other things later on, but we will get there. We'll get there.
Huh.
Yeah. Right now I'm just trying to do. Oh, hello, baby. Yo. How are you doing today? Busy day. We are trying to. I just have a little bit of time. I should actually be having notifications on my phone. But yeah, a little bit of time. And about an hour still, I think. Or maybe a bit more if I'm lucky. And still just trying to make sure that I understand the image descriptor sets for textures and samplers, so that we can then take it from the GLTF loader. But right now, I was like, right, how the fuck did these things work again? I completely forgotten about it. So I'm just trying to create one right now over here with. Yeah, okay, I should probably move it a bit. Where I actually create the textures. So I create the texture and then I'm gonna create the sampler. And I'm gonna store them in here temporarily just for the sake of this. So sampler test.
Lucas.
Yeah?
I will go to TT Chef and see what they are up to.
Yeah.
Stream if I'm not back some time ago. Later. So
Yeah.
have a wonderful day.
Yeah.
Bye.
Bye. So now we can pass in the device, and we still have some more fields to actually cover in here. Wait, hold on. That's cool. I'll be creating my actual stats system for the game today. I only have mocking. Oh, that's so sick. Yeah, no. I'm still like setting up the basic stuff. It feels so weird, but I have promised that this is gonna be the game that, of course, unless if something very, very strange happens, then of course I can't. But this is gonna be the actual game that I want to make to a real thing, right? So it's gonna happen, all right? It's just gonna happen. That's just how it is, and it's gonna happen. That's how I'm saying. It's gonna happen. And we need to provide a pointer for that one. And then we want to provide an allocator, and then where are we gonna store this thing? It's just, is it an array pointer of? No, it's just one, create sampler, yeah. Null, and then self dot sampler test sampler, don't really care. C, no. Check. I check that and do a tryout. Try. I was thinking of creating a data file for each unit type. I will just use a basic INI key value file as I have the implement to the setting, etc. I don't really. I mean, does it really matter if you just think about that? You could. It doesn't really matter what you use, I guess. Still, you don't have to, unless if it becomes like a performance issue. Does it really matter? Like, just use something that works. So I think probably what you're doing is good enough, right? Maybe I don't have JSON parser, etc. Ah, you see, I don't know. Harold will probably say that it just works in Zig. That's it's not here right now. But I think there's hold on, wait. We can actually take a quick look here. I haven't. Let's go to the GLTF model here. Yeah, because I think that's what he's using Doom Vortel for the loader here. Hold on here, GLTF. Because he creates all of these structures, which he said he just had to do it for the JSON parser. Let's see, parse here. Standard JSON parse. Wait, hold, so is there actually standard JSON parse from Slice? And then you just provide the overlaying structure that contains all of the... No way, it just works like that. Because here you get the... I have some type of for the GLB, but I haven't really done a generic implementation yet. Okay, let's see. This is the standard library JSON. I would parse JSON document from S and returns the result package in a std JSON parsed. You must call dinit of the returned object to clean up all allocated resources. If you are using std heap allocated or similar, consider calling parse from slice leak instead. Note the error buffer. Okay, so yeah, so there is like kind of a parser for JSON. I should probably like practice how to use that one, but there's a lot of things you could be doing and should be doing. I probably shouldn't even be doing this, but I find this is still kind of fun to figure out this basic Vulkan stuff. I don't know, Vulkan sounds so cool, so I just like to waste time on it. It doesn't really matter which addressing mode you use here because we are not going to sample blah 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 blah. These two fields specify anisotropic filtering and should be used. If there's no reason not to use this unless performance is concerned. The max anisotropy field limits the amount of texel samples that can be used to calculate the final color. A lower value results in a better performance but lower quality results. To figure out which value we can use, we need to retrieve the properties of the physical device like so. So if I just put it to true, I won't have it. And I need to retrieve from the physical device. Look at documentation for physical device property structure. You will see that it contains physical device limits, member named limits. This structure then returns a member called max sampler anisotropy, and this is the maximum value we can specify for max. If we want to go for a maximum quality, we can simply use the value directly. So if I just put it to false, I don't have to worry about it at all. Villager HP 25, attack 2, damage type melee armor 0, pierce armor 0, attack range 7. That's how my file will look like. I'll start with that. Yeah, I think that sounds great, man. I think it is a great thing. I'm still like waiting to get to that point where I can actually like start to... You know what I really like with Unreal? That's what I kind of would like also try to do. I don't think it's CSV files, but Unreal data assets, I think they're called, or data... I think they're called data assets. And then you have like, yeah, but is there anyone who shows how they look like? But do you know what I'm talking about? These things, they are data assets, but I can't, maybe, here's a good screenshot about it. Data assets. Yeah. Maybe they're JSON? I don't remember what format they are stored in, but they are cool. Yeah, they are so freaking cool. I remember because like it was so easy to... I just made for a tower defense game we made, so my friend was supposed to do balancing, and I just made these data assets where he could just tweak the range parameters and damage towers dealt and like attack speed and whatnot. And then he could just create new towers by pressing a plus drop down and then selecting the base class for which towers to put in there. And I don't know, I felt it was super cool because it was so convenient for him because he didn't do the programming part. He could just press a plus icon and add new towers to the game and change their values from there. Yeah. You don't want that to be encoded, but rather in files. Of course, if you're just, yeah, I don't know, like maybe as a developer, it's even also quite convenient to do these things for yourself. Yeah, so that's your villager. Yeah. Barbarian, etc. Yeah. Your entities data asset, but I love those data assets. They were really cool how you could just do this, and then yeah, you can do also these data tables, which are another wholly cool thing I really like about Unreal. But yeah. I'm just gonna put this to false, and I probably won't have to worry about it. I don't think it will look too bad for now. It's still just a test, and I want to get it running, not to get it good. You can either query the properties at the beginning of your program and pass them around the function that need them, or query them in the create sampler function itself. Sample border color. The border color field specifies which color is returned when the sampler beyond the image with clamped border addressing mode. It's possible to return black, white, or transparent in either float or int format. You cannot specify arbitrary color. Damn. Border color, CVK, border color, int, opaque, black. Black is a good color. Let's see, does it say anything in here though about the fields more descriptively, so I don't have to try to separating. No, I want to combine them. I don't want to. That's a combined image sampler is what I'm using. Vulkan image combine image sampler. Combine image sampler here. They do not talk about the field values, do they? Field. Field. They do talk about the create info over here about these things, but they do not talk about. Okay, they do talk about this properties, physical device get properties. Well, I do still have the actual physical device when I'm still doing it where I'm doing it right now, but yeah, I think this example probably covers the exact same thing, just a bit cleaner or more beautiful. I'm more used to it. That's the right answer. Yeah, so we put the border color, then you normalize coordinates. The normalized coordinates field specifies which coordinate system you want to use to address the textile in image. If this field is true, then you can simply use coordinate within text width and text height range. If it's false, then the texts are addressed using 0, 1, range on all axes. Real world application almost always use normalized coordinates because when it's possible to use texture of in resolution. Are these referring to the UVs then? I'm gonna take a look. Let's see. And it is this referring to UVs. Wow, we even got it like that. That's crazy. Yeah, okay, so it is UVs we're talking about. Good. And then we have compare enabled, false, compare operator, compare always. If a comparison function is enabled, then text will first be compared to a value, and the result of that comparison is used in filtering operation. This mainly is used for percentage close filtering. Just check one thing. Yeah, I haven't got to that yet, so materials is not interesting at all. This is the only place where I do, yeah, samplers. And then we're in the GLTF files. Okay, no, I haven't touched it yet in this project. It's like, have I actually not touched it? But yeah, I haven't touched it yet. It's okay, it's okay. Now I forgot where I was. Oh, great. Comparison function enabled. If comparison is used in filtering operation, this is mainly used for percentage close filtering on shadow maps. We'll look into this in future chapters. So we can just take that for now then. I guess it's fine. Compared. We're also gonna have to do something with the shadows in this game. It's just gonna be part of it also. But we're not too concerned about it yet. It's more of a when we get to it, when it needs to be a little bit fancier. Right now we just want to load in some basic models, right? And animations. I think animation is still more important than the damn shadows. Call me crazy if you want to, but that's what I'm thinking. Okay. Then mipmap mode. Big example, mipmap mode linear, mipmap bias, min load, level of detail, max level. All of these fields apply to mip mapping. We'll look at mip mapping in later chapter, but basically it's another type of filter that can be applied. Function of the sampler is now fully defined and the class member to hold. Okay. So I'm just gonna say 0, but by default these are already 0, so I don't even have to worry about it. And then this one can become CVK sampler mipmap mode linear. Yeah, we'll do that, and that should give us our sampler. So now we should both have a texture, a image, and a sampler. Now, how the hell do I use these with shader objects? Let's see, do they talk about it here? Maybe I can take that. Wait, create texture sampler. Create sampler. So they keep it in the same, just texture sampler, okay. If you run the program right now, you will see validation layer message like this. That's because anthropic filtering is actually an optional device feature we need. We are not even touching. And even though it's very unlikely that modern graphics card will support it, we should update. Yeah. Okay. But I just need to, now that I got these, I need to send them over to, I'm gonna show you guys, we're gonna take this over to here. And we're gonna go into assets, shaders. See, I don't have UVs, so this may be really bad. But let me see, show you. We're gonna go into, I should get rid of everything that I'm not using, but it's gonna be fragmented frag. Because it's here we want to use it. We wanna get the texture here, and then somehow I want to apply that onto. I think we may even ignore the in color. I should have different shaders for these things. No, it's fine. It's okay. We just need to get it in here. I know it's gonna be a bit weird because everything will have that now, but it's fine. It's fine. So let's see, descriptor pool sets, buffers. Descriptor image info. Sampler structure just must be specified BK descriptor image structure, just like the buffer source for uniform buffer descriptor is specified in Vulkan descriptors info. Right descriptor sets. We don't do texture coordinates here. Nah, I don't care about that. We need to take in the UVs though, but I'm just gonna get them to. Well, we could get the UVs while we're at it right now, just to follow up with that thing. So we do get the positions. Here I'm trying to get the material. We're still on the to do materials. To do material. We're still gonna get it done, but for now that will be it. And then we'll do const UVs. UV, is it the accessor as well? We're gonna keep that one as okay. Oh my god, it's such a force of habit. I usually have the NeoBeam to open up in terminal when I do that, and I was like, yeah, let's just reboot the whole system, I guess. Ain't no way that just happened. Ain't no way. Oh my god. Well, that's okay. It was not funny. Did not laugh. Did the stream just resume or did it completely start a new one? I think it just started a new... No, it's continues off from the old one. Okay, so it just broke there for a moment. Oh my god. That was scary. I wonder, can you see it on the stream that I actually like kind of goes through the... You can. You don't see me type reboot, but... That's friggin' crazy. Oh my god. Well, it's okay. It's okay. We're back now. Oh my god. I'm a bit wait, you guys don't see anything there. Okay, we're not gonna make the same mistake twice, right? Hopefully we won't. I'm just gonna... I don't know what I dare to do now. We're gonna go back into here, we're gonna start a new terminal. And we're gonna type manually that in there, and we're gonna start another one. Ooh, this is scary. Okay, no, it's not scary, but man, I cannot fuck it up again. We're gonna go into shaders for this one, because I know we're gonna be touching shaders. That I know. Then we're also wanna check the objects real quick here for GLTF real quick. Where's something simple? Penboso is one that I'm working with. And what I want to do is I want to... What the fuck just happened? Yeah. Reopen it. Source, render, Vulkan, and found swap file. Open, quit, abort, edit. Can I not just like resume edit? Why can I, what? Another problem may be editing the file is edit for the crash. If this is the case, use recover or recover. Can I not recover there? So, did I get it or did I not get it? I think I got it. I have no idea. I'm gonna save it. Now, that's... now, the thing I want to see is UVs. UVs should be another attribute, what are they called? Attributes, normal, text coordinate 0 here, and text coordinate 0 and these ones. And so I want to get this thing. So it's another, what should I call it? Accessor position. So UV accessor, and then IDX is equal to P. Now, let's go. There's no LSP. I don't even get colors. Could you please not? I already typed recover to get it back, but to recover changes C help to recovery. If you did this, delete the swap file. Okay, I will do that. Wait, delete it. There. It's equal to P dot attributes dot map get, and we're gonna get this. Boom. Or we're gonna do an or else error, because that's what we're gonna do. No UV. Now with that, we should be able to get the index for it, and that's just UV accessor. Accessor is equal to G access source, and then it's gonna be like this, and then we're gonna provide it with the UV accessor index. We could probably call it just UV index. Anyways, we go through here, we go get the accessor, and wait, hold on, it said that it's 2, so we have 0, 1, and 2. It's buffer view 2 as well. Buffer view 0, 1, and 2. And byte length, byte offset, so we do need to get all of this information also. And then target, what was target? I don't remember. But this is basically the same that we have been doing already for position. So it's the buffer view, and then the accessor has the buffer view, yes, and then positioner buff offset plus the buffer view byte offset. Can these things actually contain a offset on their own? Well, sure. And then we'll have the offset. And we are gonna make the assumption this is in general probably not the note. Probably should check the... I don't know. Can we just make that assumption? Isn't that fine? I think that's fine. Can I do that? Thank you. We're gonna do the same thing as we have done over here, but with this thing instead over here. The expected. Okay, good. Use const. Like that, and we are gonna change these for these ones, and then buffer view, UV buffer view maybe. You could also just make it a local, like I do with the indices. Just like this, so you have this thing, and then we could reuse the information, but it's fine. UV offset, and then we're not going to be using positions. Instead, we're going to change this to UVs. And what we're going to do here is, binary, and then we're going to go from. We're going to be using the UV accessor. And these are actually just gonna be of 2, not 21. But is it valid to make an assumption that they will be F32s? That I don't know. Maybe they can be something different. Let's see. I'm gonna go down. Do we get the accessors? And it was 0, 1, and 2. Type vec2, but can I wait? Where do I see the here? Yes, type is a vec2. Zero, 1, 2. It's a vec2. It says buffer view 2. 0, 1, 2. I don't know. It just says vec2. Can I not type? Hold on. No, that's all I get. Component type 5126. Yes. 5126 is though a F32, I think, if I remember correctly. Let's see. We can open this one for that. Should I? Yeah, sure. It's a GLTF and 26. It's a float, yeah. Can it be? Well, we can do this, right? We can do this. We can do std debug assert, because this will only happen when we're developing. Sorry, I don't have the chat open. Sorry, guys. Hello. Maybe you got a sub. Sure, Porty Parrots. Hello. I don't know if anybody saw, but I accidentally during the stream says that it has been a continuous stream, but if you go about 5-10 minutes back somewhere there, it's funny because I accidentally I created a new terminal and did arrow up, and yeah, there's a reboot. I thought I had NeoVim there, and I pressed enter, and I rebooted the whole system. That was fantastic. It was nailed it, 100%. But yeah, invokes detectable illegal behavior when OK is false. So assert that uh, position accessor dot what is it called? Component type. Component type is equal to, can I easily get this from GLTF component type and then float? Because if we ever run into the point where this is not the case, well then I think, wait, I cannot do that. Struct, no field name, component type, okay, in accessor, I thought there would be. Let's see, accessor type, access, maybe I'm doing it wrong. Let's see, accessor, oh, it's lowercase component type, okay, so now we can spell like that, okay. And the same will be done for the UVs, UV self-component type float, isn't the type, okay, it stores a U32. You'd have to be joking. Okay, it's okay. If I go back up to, okay, component type, but I know it's gonna be component type. It is though an enum, so if I just take it to an integer back, add int from enum. So now we will return that, yeah. And then we'll have this thing, and I will pretty much do the same assertion here, but with UVs. Because if it is at any point something else, then I know that I will have to change this. But if it's not, then I will just continue working with as if it is like this. So we'll get the UVs. And then we'll get this. Well, UVs should always be a vector. If it's not, then can it be a 3? I'm not even gonna consider if it can be a 3 or 1-dimensional UVs. That just we're not trying to be generic here, okay? Or yeah, I think that's for general use cases. We're explicit for whatever I'm trying to make. That's what we're making this for. And if it's something else, then I just want to be notified in build that, okay, now you're trying to do something that you haven't anticipated. Maybe it's time for a change. But until then, we're not gonna try to do every kind because that takes time. Everything takes time. So now we got this thing. We got the UV buffer view, UV offset, and then with that, we should be able to, yeah, we should be able to do this now. UV underscore offset, like so. And then this one also has to be UV buffer view, otherwise it will not be good. And then we get all of the views, and then pretty much the same thing that happens here, but this is position accessor. How should I think about this now? Can I make... What if they are not the same? How can I... They have to be, right? There's no way they wouldn't be. That would be freaking weird if it wasn't. Let's see. Count... Yeah. Hold on. Because we go in here... We say 0 and let's say 2 and 1. They have to be the same. There's no way they wouldn't be. 0 says there's 559. Normal's 551 and 559. So it's safe to assume that, I would say so. I'm gonna see if I did this. Illegal. If I did the same thing in my previous project, I'm gonna make the assumption that this is fine. This is fine. Render assets, load the GLTF. And basically what I did here, I got all of these things, the images, materials, and then here I started to go through each mesh. And I got the primitives, then I got the indices and the position accessors, and then vertices list, I just yeah, I did this to all of them. Okay. Then I got the normals. Wait, ensure total capacity indices list. Yeah, okay, and then I just gave this. Then I did the normals, the UVs, and the colors. And I just initial VTX. Okay. But that's the same, it's the same that I did for this one over here. But this one is a bit different at the same time. Because I don't even need to do that, because I already get a slice that points to that place where I'm working with, so I don't even have to worry about the initial VTX. It's just a simple same thingy. So they how did I get how many I should do? Or position, yeah, and then in this, well, the only thing that could happen is that then the last few verses wouldn't have a UV or a normal or something like that, or color for that. That's the only thing that could happen if we play around like this. So I think it's safe to assume that they are the same. And if they are the same, well, now we basically got the information about them, right? So we also going through this thing. I think it's alright. I think we could even make it a little bit nicer to work with. We're not even gonna do positions like this. We're gonna do this. We're gonna remove it from here. And we're gonna take it in here like this. Even though it gets longer, but I think now it's a bit clearer what we're working with. And then you... Fuck me. No, this is fine. We can just say UVs I, and I would assume that it's 0 for this one and 1 for the second. Like that. And that should give us the UVs to the unused local con. No, okay. So we should be getting the UVs now into all of the vertices. Maybe, hopefully, I believe. And with the UVs now, we should be able to, if you go into here, now I'm getting to the point where I do get the UVs also in the shaders. Fragment. I think I took them through vertex and passed them on to the... I think I may have done that actually. Shit. Let's take a look. We're gonna go into the fragment. We're not even in shaders. Fragment frag. Location. I don't even do the UVs in here. What the fuck? Vertex vert. Yeah, I get them because I only get them into here. So if I want to take them in the fragment, because I use the address, so I only pass like the pointer to the array where it exists on the graphics card. Graphics cards VRAM, and then I iterate it to access the right vertex that I'm working on instead of passing a, well, what are they called? Uniform buffer. Instead I have this thing. Uniform buffer? Am I saying the right thing? Anyways, I'm using these things. But I do have access to the whole, the pointer also in the fragment shader right now, so I could access it the same way that I do from here. And I would have all of this information, or I could pass them through the in and out. I think it's probably cleaner to pass them as UVs. And also gonna prefix it with... okay, I'm not gonna prefix it. What the fuck? Out. Should I start redoing... I'm gonna do it like this. Have it like that, so I'm gonna continue with that. And then... But this one is also going out, so then it has to be 1. And we're gonna call this one out UV. Like so, and it's gonna be big too, so I think like that. And then we're gonna provide here out frag. And then we're gonna do an out UV is equal to vec2 of a vertex, and then we have the ux, and we're gonna have vertex uy, and that should be okay. We just have to take it in on the other side. So this is gonna be an in now, so we can change it to a. I don't think I use color at all. I do use color. What the? Yeah, I'm dumb as fuck. Don't worry about it. I'm gonna change it to an in on. Can I type in UV? And yeah, more than that, I don't really remember how we now actually use that information. So now we have to take up the tutorial again. See if I can find it. Da 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 da. Here, let's see. What do? They do geo position. Yeah. And then they pass it through, but I pass it only to the fragment. Unless if I'm doing it wrong, you know, that could also be possible, but I don't think so. Which shader? The final step is modifying the shaders to color. To sample color, we first need to modify the vertex shader to pass through the texture coordinates to the fragment shader. Yeah, that I did. Frag texture coordinates. Yeah, okay. Yeah. And okay, yeah, it's just slightly different, but it's the same thing. Just like per vertex color, the fragment texture values will be smoothly interpolated across the area of the square by the rasterizer. You can visualize this by having the fragment shader output the texture coordinate as color. So frag texture coordinate, so you get it like that, and then okay, out color, so that's, yeah, okay, then you can, yeah, okay, I think I remember this. Like for, we're probably not gonna use, we'll look into it, but in UV, oh wait, yeah, but then I somehow need to get the texture sampler, yeah, texture sampler, and then a fragment coordinates. Okay, we got this. We still have to upload it there, or like tell it how to access it, but I think we're getting there. Texture, is it like that? Texture sampler. Okay, I think I could call it also texture sampler. It sounds cooler. And then texture sampler, and then we provide the in UV. So that should now do that. We just need to, I think we have everything set up except for one thing. I'm pretty sure we're missing one piece right now, and I cannot really say for sure where it is at. I know it's one thing that I'm missing. Because you're right, because they don't have to worry about it, because they're not using this is the part that is different for me compared to theirs, because I'm using shader objects. They are using just traditional pipelines with descriptor sets. I just don't. I use shader objects. So how the fuck do I do that with shader objects? Let's see, I think I could figure it out. Maybe I should actually read about it. Shader objects, combined image sampler. Combine image sampler or descriptive Vulkan that bind image resource sampler object into a single blah 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 and content blah 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 blah. Okay, let's ask Claude. Hey, in Vulkan, shader objects combine image sampler. How do I tell the shader object to be found to the shader? I don't know. The shader object. What did I just type? Well, I think it understands my question. Your question got a bit garbled. Yeah, and my invoking the shader object extension. How do I bind a combined image sampler? Create a descriptor layout binding. Then, how do I tell the shader which descriptor set layout its use creation time? 1. I got stroke there, I swear. Because I'm telling it. Let's see. Because it's a uniform, right? So shouldn't it be something similar to the other uniform that I do here? No, not this thing. That's the only thing I have with uniform. What the fuck? I swear to God, there should be something that tells me that I should be able to do something different. Begin rendering offset. Ah! Wait, I think it's somewhere here. Current frame. Yeah, this is where I work with the frame information. So shouldn't I be able to? I want to do it per mesh, per material actual update. It should be able to happen. Because if you think about it, that or surface, each surface could have a different material, which means a different texture, which means a different sampler or images. So it should be actually happening here in this loop if it's a different from before. And right now that won't be the case, but descriptor set layout with combined image sampler. Yep, set layout create info. But yeah, this I do already. Yeah. Oh wait, this is not. No. Hold on. Here. Yeah, and there I have already provided it. But descriptor set layout binding. Oh yeah, that's the thing that I passed right into it, so it's the same thing. And then I provide that, it's done. Pipeline layout, create layout info. Well, it's also passed in there, don't have to worry about that. Don't have to worry about that. Bind descriptor sets, here. This is what I want. What the fuck is that descriptor set? But we'll combine descriptor set, and then I think this is what I'm trying to find. I'm pretty sure it's something like this. Bind descriptor utils here. Bind descriptor buffer extension. Right, this was slightly different, but now we would like to it's actually gonna be happening down here, but I think we can take it from here. To do per material, per, I don't know what to call them still, sub mesh material instance. I'm just gonna call it that, but for now that's fine. And descriptor sets, there's 2. Let's see. But there I'm gonna provide a pipeline. First set descriptor sets. I think it's messing up. Like I don't have. Sure. Let's. Removes the pipeline and the giant graphics pipeline create info, but it does not remove the descriptor system. Combines image sampler and found, but it should get rid of the descriptor pool, so I shouldn't be able. If your unit have no descriptor sets right now, then the shader literally cannot see the texture yet. You need layout. No, this is what what it should get rid of, if I understood correctly. Shader of sure. The and sets. Or you can use them. Not shader objects. These descriptor buffers. Well, I also have the buffers. Shader kills the pipeline. Descriptor on. Kills descriptor pools. You manage descriptor memory yourself in regular VK buffer. Decompose, use both, and you're getting no pipelines and no descriptor pools. That's almost certainly what you want. Okay, maybe I misunderstood them, but that's okay. We can still use that thing over again, but I thought that I read about it. Fuck, I was thinking of doing some tooltip additions now with stats. Let's see. But I don't really have a rigid tray casting solution. Oh man. Man, time moves so fast. Okay, whoa. So I can't like hover a unit to get tooltip. Damn. It works as expected. AI, what the UI? What did I say? That's good. I'm so glad. Damn. You need to post a GIF or something of progress in the projects section. Damn man. D-man. Let me quickly Vulkan shader object. Oh my god. Because I'm pretty sure it's like you can still use descriptor sets, but cool. Okay, does shader object get rid of descriptor pools? Cool. How? No, shader do not limit the need for descriptor. According to the Chronos forum discussion, shader objects are more flexible alternative to shader modules and pipeline objects. Descriptor pool the faction. Okay, so then I would like to change it to be using because I really don't like it, and I don't have a descriptor pool, and I don't really want to create one because I find them so confusing to deal with. I'm thinking of descriptor buffers. Yes, that's what I'm thinking of. With descriptor buffers, the flow is you still need a descriptor set layout that I got. Descriptor set layout create descriptor buffer bit extension I got. It's schema not an allocation. The layout is still goes into wiki create info pset layout. And then instead of pool set update, get descriptor size. Query how big a descriptor is and where it goes in the layout. Get descriptor set layout binding. Get descriptor set layout size extension. Size. So that size so gets the size. Get descriptor set layout binding offset. Allocate buffer with VK buffer usage descriptor buffer extension. descriptor image info. Write the combined image sampler descriptor into a mapped buffer. Descriptor get info. Get descriptor. I don't think this is the right way to. Descriptor size comes from. Okay, I'm gonna check. Upload textures, shader objects, or combine image sampler or whatnot. To upload and upload textures to shader objects, first import image file into your engines of what the fuck? It's thinking I'm just using some Unity stuff. What? Vulkan. I didn't even know that engines had such a concept. I know that they use them, but like that the off-the-shelf game engines just had like for you to use them. That I didn't know. Using shader objects follows the fundamental memory management and command reporting steps as traditional pipeline. Texture upload process. Creation, copy, layout, integration with shader objects, pipeline, sampler, command bind, shader, pipeline, layout, command bind, descriptor sets. Yes, but then you need that thing. What was it also called? There was a new one that was being I don't know which version it will be in. I think it was in the development, if you use development tools for NVIDIA, you would have access to it, right? What was it? I don't remember. There was some extension. Heap? What's it called? Heap descriptor set? Or something like that. Which would probably be more ideal, and then I wouldn't need to worry about the things that I'm right now trying to avoid. But we'll see real quick if I can, if this mirror would load. This is my gigantic mirror where I have like every thing. It's taking too long. We're gonna do something else in the meantime. But I don't know if it loads if I don't have it focused. Hopefully it does. And I may have to go in any minute right now, so shit. But it's okay. We're gonna be fine. Loading images, Vulkan and Rust textures. Fucking Christ, you're joking. Okay, well I think maybe it's right then to do this Vulkan buffer bit. So then I would have to do the same thing that I do for this thing over here, but why I don't do the size check? Should I actually be doing that size checking? I didn't do that. I don't know if I should be doing that, but because I literally just go here, descriptor set layout, then I just say this, right? Descriptor type inline block uniform, right? And then set the create descriptor buffer bit. Wait, I do it for all of them anyways, so okay, I think we're chilling. I probably have access to it as that already. So I should be able to just I mean let's see. What are the steps I do here for this thing then? Because I do a scene, I get the data, scene copy, I copy the scene data. Into this one, and then BK buffer address info. Get buffer device address, and then I just get this thing info, and then I what is that U32 for? maybe amount or the which set, and then okay, I think this is probably what I would like to be working. Yeah, okay, I'm just gonna provide it with this information, or actually what we could do, I think this is smarter, just to confirm, because I think this one still has a little bit more information. I got everything ready to use textures, I think, but how do I now actually do the Vulkan command to connect or send the data, connect the data with the shaders uniform texture layout? Let's see. Yeah, sure. I should probably have done. No, it's fine. While that one is doing that, we can probably go in here and it's still loading. You're joking. I should probably like delete this thing if you can't even load into it. Like, okay, it's just one more bar. Okay, there. My masterpiece, my artwork. Here we have it. I remember these things. The thing that I'm interested in is, well, first we can also open that one real quick. But push descriptors. This was the thing that I'm wondering, like, when will this become a real deal? Because I understood this should make it some uniform image layout. This should make things so much better if I could just use that. I'm not a robot, trust me. Okay, good, it trusted me. Let's see, pool. There's nothing on pools. Yes, I must have hallucinated that. When is this becoming a real thing? Extension number 81. This extension allows descriptors to be written into a command buffer while the implementation is responsible for managing their memory. Push descriptor may enable easier porting from older API. And let's see. New command. If Vulkan or... Wait, can you use this now? I don't remember when the last time promotion to Vulkan 1.0 function. This extension is included in core Vulkan 1.4 with Chronos suffix omitted. The original type enum. I remember that or am I mixing this up with something else? Because it was something with this that I wanted to use, but I didn't see. Shader objects, yes, but where? I swear to God, I saw it somewhere, and I'm not sure if that's the one I'm thinking about right now. Well, let's see. What does it say in here? And this is using descriptor buffers extension, not regular descriptor sets. That changes everything. Let me check the layout frame and image structure. Now I have the picture. The C layout image ends. You're using classic, not classic, so there's no update descriptor set and VK descriptor sets. The connecting step is VK get descriptor extension, which writes descriptor bytes into a buffer. Then you bind. You're already doing bind half. What? VK bind descriptor buffer extension plus VK set descriptor buffer offset. But nothing is being written for binding one yet. That's missing piece. What? But this thing works. I don't know what it's talking about. What needs to happen for VK descriptor set layout? Oh wait, but that's because, okay. For each descriptor set layout, the layout has a size and each binding has an offset with that size. Your descriptor buffer must be at least that big. You write each descriptor sampler image sampler image uniform buffer into the buffer at binding offset by calling descriptor extension. The GPU then reads those bytes when it sees VK set descriptor buffer. Wait. Into the buffer at binding offset by calling VK get descriptor. So you write it by saying get. That's weird. Get descriptor. Well, there is no such thing, so I don't know what he's talking about. Or maybe that's because I'm not using the GPU then reads those bytes when it sees VK's command set descriptor buffer set offset extension. A concrete step for your binding one combined image sampler. Load 3 more proc. I need 3 more const function device descriptor set layout. Set layout. Get descriptor set layout size. Set layout binding offset and set layout. It's already loaded. Query descriptor size alignment once during init chain. VK physical device property buffer properties onto physical properties 2 and read combined image sampler descriptor size and descriptor buffer offset alignment. The first is how many bytes this provides for a combined image sampler. The second is what you have to align buffer offset to. Resize the buffer today is sized for just GPU, the line inline block, and only has resource descriptor buffer bit. For binding one, you need usage flag, VK usage sampler descriptor buffer, added combined image sampler, add a combined image sampler count as sample descriptor size, call this once and use that as a buffer length. Each frame once if the texture never changes, write binding one descriptor. Each frame or once if texture never changes, yeah, write binding once descriptor. But I need to write it every time because I need to update the damn... Wait, no, each frame. Yeah, no, each frame, it's just once. But the texture never... Well, the texture can change. Because we are loading different things, so yeah. Offset. And then get descriptor binding, okay. Each frame or once, okay, just got a stroke there real quick. Descriptor image in sampler, okay. That pointer field is... I just have it called data, I think. But I'm gonna see quickly that I'm not mistaken. Also, to do this for bindings for the inline uniform block descriptor is what officially copies your GPU. I think it has something misunderstood. But is it then this thing? No, I want to say it's something called heap, but I don't remember where I can. Did I have descriptor index? Descriptor indexing. Did I not save it? Now I'm starting to get pissed because this should be somewhere here. No. Okay, I can ask here. Let's see, I'm gonna take... I'm pretty sure it should have been... If not this, then it should be heap descriptors or whatever it was called. Let's see. Vulkan heap this. Wasn't that what I just copied? No, it wasn't. Heap. Descriptor heap. Extension of explicit manner of descriptor and memory used to store descriptor and concept which is is it sets for neither of those names quite right, and one of them doesn't exist. Not a thing you may think of. No, okay, so it's probably this one. Realize it removes pool sets, but in much more limited way. You call descriptor writer in line at the command buffer, not pool. No allocated set. No. You still need descriptor set layout created. Create descriptors bit and a pipeline. Push and a pipeline layout. It's meant for small frequent changes binding low limit. Okay, yeah, okay. I think it's probably then this one because it doesn't even find references to it. Oops. Let's see. Floaters ignored binding zero is fragile tangent. Binding zero works because the inline uniform block bytes EUB at offset 0 happen to be just the raw EU data, so writing jeeps indirectly to the buffer is equivalent to what? Right, that fine, leave it alone. The real question is just how do I get binding 1, the combined image sampler, into the same descriptor buffer? It's missing, but do I want it in the same? I'm a bit unsure how. Well, I guess I do, yeah. The function whose entire purpose is to convert here is the image view sampler into the opaque bytes the GPU expects at offset X of the descriptor buffer. Right now nothing writes those bytes, so binding 1 is reading garbage. Add 2 procs. Okay, we're gonna add these two. Assuming that these are the actual signatures and whatnot. We can check it when we try to compile, but it's probably not. But and it's a device extension, I would assume it is. Where do I have the other descriptor sets? Well, I have them over here. So I'm gonna add them right. If I save it out, I'll fix that. Okay, let's see just that it did the right thing. It seems to be alright, so I think we can assume that it is. And then we've got those query descriptor size once during init. Okay, physical device descriptor buffer properties. I should probably have like some info table stored in the physical device. I think we're kind of getting to that point where I'm starting to see many places where I would like to have that. So I think we're gonna go for that. We're gonna create, I think it's a physical thing. Physical device. And what should I call it? Just properties? I think properties is a great name. Public. Public? Yeah, public. It doesn't need to be anywhere else, so I think I'm just gonna go. Well, does the LSP? I think LSP still works to access it. Properties. What the fuck is properties? Properties. I think that's right. Properties. And we're gonna store. I would like to store both the now when we're on it. The actual which we had from here that I wanted to do was this image sampler. Because I did just the uniform coordinate. No, what the fuck was that? It was this. But I don't know. Max, that's an F32. So I think we can take this one while we're at it. We're not gonna use it, but I'm gonna take it while we're at it. And we can go back to here, paste it there. We're not gonna call it that. We're just gonna do that. It's gonna be an F32. Not gonna get the default value. And then we can go back to this one over here, and then max sets. I think we have to go one page back. Max there. And then we get it from physical device properties, because and then in the properties there should be structural CA contains physical limits, and inside of the limits we should find that. So we're gonna go through there and get it. And I should get physical device properties somewhere. Physical device Q family properties. Physical properties here. And then when we return here, we'd almost put the Q family inside of properties. Maybe. Yeah, nah, let's not do that. We can store the. These are all just integer values. So I think it's fine if we do a. We can do a at the. We can do at the top. But then now querying every time and assigning it. That's too.
Are you live on YouTube?
Hello? What? Oh, it's snowy.
Hi, YouTube.
I'm live on YouTube. Yeah. Am I not?
Welcome back, guys. Today we're gonna say the N-word.
Oh, fuck. Not again?
What do you mean again? What? Lucas.
Alright. Actually, wait, it's so sad that you joined right now because I actually need to go right now.
Big F.
Yeah. But I just need to show you something before I go, and for anyone who's watching the stream who's maybe slightly interested in my fiascos. It was so funny because it was like somewhere around, where was it? I was yeah, okay, it's still further. Yeah, here. Oh my god, it's so funny. Yeah, okay, I think it's right here. I'm just gonna slow the playback speed real quick. Okay, look at this. I was trying to. I opened a new tab. I was working on the UV shit, right? And then I go in here. I open a new tab. There. And then you don't see it here in the frames, but I pressed the up arrow to get the recent commands, and I thought that I had Neobim as the recent command. But I didn't have Neobim. I had reboot. And pressed enter. And then the stream just died.
That's well done.
Nailed it. Oh my god. Okay. But yeah, I have to go. See you later. Take care, everybody.
See ya, bro.
Bye bye.